Hi guys, so this is the second video to show you how to solve the problem that's on the formative. So let's get started. The first thing we're given is that we're given three numbers that sum to 84 and they determine a geometric sequence. So let's write this down first. So we've got a geometric sequence. We have three numbers, so let me call them A1, A2, and A3. Their sum is going to be 84. Next thing I'm going to do is they represent the first 7 and 19th term of the arithmetic sequence. So the first term of the arithmetic sequence is B1. We know that B1 is the same as A1. We don't know what B2 is because we just know that the 7th term would be the same as the second term in the first sequence. So B7 would actually be the same as A2. And finally, B19, the 19th term of the arithmetic sequence is the same as the third term of geometry. So this is the information we're given. Now let's try to solve this. So like I explained a couple times, we want to start with the information that's really obvious. In this case, the sum that the first three terms equals to 84. So of course, these belong to a geometric sequence. So I'll write this down again just so that we're clear about that. It's a geometric sequence. We know that for a geometric sequence, the sum of any term is going to be equal to a1 times r to the power of n minus 1 divided by r minus 1. So again, this is 84, and then you've heard me mention a couple times, this is equal to a1 times r to the power of 3 because we're summing three terms, minus 1 over r minus 1. And we've broken this one down before into r minus 1 times r squared plus r plus 1. So this r minus 1 basically cancels out, which is going to give us the same format as the equation as we've seen before, which is 84 equals to a1 times r squared, that's a square, plus r plus 1. So this would be here, of course, one of the equations we are going to want to use to figure out what A1, A2, A3 are. So I'm going to call this one, let's call it star, first star. So how many unknowns do we have here? Remember, I always want you to look at how many unknowns. We have two unknowns, which means we need one more equation to be able to solve this. Now, what equation we're going to need to use is a very big question, because if you want to look at your geometric sequence a little bit more, the other thing that you could use is the geometric mean. But if you try that, and I urge you to try it if you want, you should get something like a1 squared times r squared equals to a1 squared times r squared, which is absolutely useless. So this won't get us anywhere. And because of that, we're basically condemned to go and look at the arithmetic sequence. For the arithmetic sequence, in this case, we have no idea what the sum is. We cannot use the mean because the mean would require us to use B1, B2, B3, or at least any three terms that are coming one after the other. And in this case, they're too far apart to be able to do something like that. So this is not going to work in this case. We're going to need something else. So symmetric property won't work either because we would need four terms. We only have three. Really, the only thing I can possibly think of is using just a general term of the arithmetic sequence on B1, B7, B19. Well, B1 will help because it's just the first term, but B7 and B19 might lead us somewhere. So let's just do that. So we're going to look at the arithmetic sequence, for which you all know now the general term is given by A1. Let me use B's because we don't want to confuse things. So since our geometric sequence, arithmetic sequence uses B's, I will use B's as well. So Bn equals to B1 plus D times n minus 1. And the thing we are given is that B7, so we have B7 and B19. So B7 should be equal to B1 plus 6 times D, because in this case, N equals to 7. I can write it in brackets to be sure it's all clear for everyone. Since N equals to 7, you would sub this in here and get 7 minus 1, which is 6. So now that we have that, remember that our goal is to get something which only has A1s and Rs. So we don't want to keep our Bs. We have to figure out a way to swap them. We can swap it using A1 and A2, because B7 is really A2 and B1 is really A1. And we've got our 6D here. And like I said, our goal is to have A1 and R. This A2 here is a little bit annoying, but we know that A belongs to a geometric sequence for which the general term is always given by A1 times R to the power of N minus 1. So I would swap that here. So this becomes A1 times R. This is A1 plus 6D. And there's nothing else I can do with that. So let me box this. If you look at this equation, we have one issue with it. And that issue is that there is in fact 3 unknowns, A1, R, and D. So here I would actually cross this out and say, no, it's not 2 unknowns that I have, it's actually 3. So if I have 3 unknowns, it means we're not done. We need one more equation. Thankfully, we are given 2 terms B, so we have B19 as well, so we can do the exact same thing, and in this case get another equation which also has the same 3 unknowns, and then we would be fine afterwards. So if I do that, I get, so we are dealing with B19, so B19 is going to be equal to B1 plus 18D, because N equals to 19, which means in the bracket we get 19 minus 1, 18. So B19, now again we want to get A1s and Rs, so let's get started with our A's. So B1 is A1, B19 is A3, I'm sorry. So B19 is A3, and B1 is A1. This here is still 18D. Again, we don't want A3, we want something that has A1 and R, so A1 R squared equals to A1 plus 18D. And now we are in business because we have 3 equations, 3 unknowns for which we will be able to solve for. So I'm going to call, I didn't want this square. So I'm going to call this here 1 and 2. And the reason for that is because if I work these equations around a little bit, I'll be able to get 2 variables to cancel out, which is going to be really convenient in solving for one of them. So to solve, let's do that. I'm going to use first 1 and 2. And I'll try to create a system and see what I can get out of it. So if I take first, actually, I'm just going to start with 1. May as well do it one at a time. So what I'm going to do is I'm going to rearrange it. I've just noticed that when I was doing the problem, if you haven't, you can just work your way around this idea. But what I could do here is isolate the D's in each of these equations. And by isolating the D's, I'm going to get my A1Rs on one side of the equation, which means that just like our other geometric problems, we'll be able to factor out A1, potentially more than A1. And once that will be done, we'll be able to divide the equations, and then we are going to get 2 things to cancel out, D's and A1s. And if that happens, we're only ever left with R, and if we're only left with R, then we can solve for it. So I will do that in the next video.